Hello guys, welcome back to my channel. Today I'm here with a new language, SQL, Structured Query Language. SQL is a basic database language which helps you to handle data into the database. Okay, you can create data, you can insert the data into the database, and you can fetch the details of the database of the data which you have inserted into the database by using SQL. Okay, we shall learn about SQL clearly in a step-by-step manner in this series of tutorial. This series will be completed within somewhere around 7 videos. Okay, it may take 1 or 2 videos more, but it will be completed somewhere around 7 videos. Okay, so now let's get started with our tutorial. Okay, let us start with a basic definition of SQL. SQL is a database language used to create, manipulate, and retrieve data from the database. We have different types of commands to do these operations: DDL, DML, DQL, DCL, and TCL. So we shall get to know each and every type of commands clearly. Here we have the overview of SQL. Firstly, we have RDBMS concepts, and then we'll get into the basic syntax, data types, and different types of operators. And then we'll start creating our tables. That is, we'll learn our DDL commands, and then DQL, DML, DCL, and TCL. Finally, we have some built-in functions in SQL. So let us get started with RDBMS concepts. RDBMS stands for Relational Database Management Systems. That is, RDBMS is a form of database management system with a set of rules. The rules which allow you to create the data which is relational in form, so that we can reduce the data redundancy, that is the duplication in data, and we can also have ease in access to our data. In relational database management system, we'll store the data in the form of tables. Okay, so a table is basically a collection of some columns with its respective rows. Okay, here we have a sample table here which has the column names on the top row, and the remaining rows are for our data entries under respective columns. Okay, now we know what a table is. The next concept of RDBMS is normalization. Normalization is the process by which we can organize the data into our tables more efficiently, so that we can have ease of access to our data. Okay, the basic concept of RDBMS is to have easy access to our data, right? So by following the rules of normalization, we can easily access our data which we have created and inserted into our database. Okay, so basically we have 4 normal forms: first normal form, second normal form, third normal form, and finally the boycott normal form. The boycott normal form is not necessary, but if you want you can use it. Okay, but in this session we'll discuss only 3 normal forms. Now let us get started with the first normal form. Within the first normal form, we basically have 2 rules. Okay, the first rule is that each and every column must have atomic values. That is, any attribute or any column cannot have 2 or more values for a single row. Each and every row must have only a single value for a column. Okay, and the second rule is that each and every column must have a unique name. That is, if we have a table with 4 columns, we must have 4 names for 4 columns. Each and every name should be different. Okay, we cannot have same name. Even if the data type is different, we can get the select anomaly if we have the same names for 2 or more columns. Okay, now let us understand the first normal form with a basic and simple example. Here we have 2 tables on the screen. 2 tables with 3 columns, and the first table has only 2 rows, but the second table has 5 rows. Now let us compare these 2 tables with regard to the first normalization form. Okay. Firstly, checking with the first table. Okay. We have three columns, namely student number, name, and course, right? And the second table also has the same column, student number, name, and course. Okay. Each column, there are three columns, and each column has a different name. That is, each column name is unique, right? So both the tables satisfy the second rule of the first normalization form. Okay. Now we have to check the first rule, right? Coming to the table 1, we have three columns. Let us check each column one by one. Starting with the first column, student number, we have two rows here. The two rows have each one value, right? We have first row has a value 1 and the second row has a value 2. Okay. Each row has only one value, so there is no problem with the first rule for the first column. And getting into the second column, name, we again have two rows and each one value. So the second column name also do not have any problem with the first normalization forms first and even the second rule. And getting into the third column, course, we have two rows here, but the first row has three different values, C, C++, and Java. And the second row has two different values, Java and Python. Recalling the first rule of the first normalization form, each column must have atomic values for each row, right? They must not have more than one value for each row under each attribute, right? So the first table do not satisfy the first normalization form, as under the course attribute we have more than one value under each row. Okay. So now checking with the second table, we have three columns again. Checking the first column, student number, we have five rows. Five rows each has only one value, so that's fine. And getting into the second column, we again have five rows. Five rows each have one value. Okay, fine. Now getting into the third column, even the third column each has one value. That is the main difference between our first table and the second table. Okay, the first table do not satisfy the first normalization form and the second table satisfies the first normalization form. Okay, now we have a question. What is the use? Both the tables present the same information. Then what is the use of a table having 5 rows instead of having a table having just 2 rows? Okay, so now let us discuss the use of having such type of table formation. Okay, now if you want to access the data about all the students who is studying the course Java. Okay, now we want to access the persons who is studying the course Java. In case of second table, we can have an easy access. But in case of first table, under the course, the SQL interpreter will store the course as, for John, it will store the information for course as C, C++, and Java. When we want to access only Java, it cannot return the information about the particular person, because it stores all the strings C, C++, and Java as a single string. So you cannot have access to any student's information if you want to have access to particular course name Java, right? So that is the difference between the first table and the second table. The data in the second table is easy to access, while the data in the first table is hard to access. Okay, so with regard to the first table, it gives a select anomaly while fetching data from our database. Okay, so that's the main advantage of the first normalization form. Now let us study about the second normalization form. Okay, to be in the second normal form, the table at first should be in the first normal form. Okay, we have to check that if the table is in the first normal form or not. And then every non-prime attribute should be fully and functionally dependent on prime key attributes. A primary key or prime key is a field or combination of fields in a table that uniquely identifies each row of a table. A primary key or a prime key attribute cannot have a null value, okay? By the null value, it doesn't mean that it cannot have 0 as a value, okay? 0 is a particular value. A null value is that, for example, just assume that while creating and inserting the data into the table, you have not given any value to a particular field, okay? Then it will not show any value in that particular field while fetching the data. That is the null value. If you do not give any value to a particular field, then that is called null value. A table do not allow to give a null value to a prime key attribute, okay? And a table can have only one primary key, which may be a single field or a combination of multiple fields. A multiple fields acting as a primary key is called a composite key, okay? We shall discuss about this more clearly with examples while discussing about constraints, okay? For now, just remember this and let's get into the example of second normal form. Here we have a simple table with 3 columns, right? We have column name, student number, course and fees. The 3 columns and 5 rows, right? So let us check that if this particular table is in second normalization form or not. Okay? To check if that is in second normalization form or not, firstly we have to check if it is in first normalization form or not, right? So let us quickly check with that. We have 3 columns here, student number, course and fees, for which all the column names are unique. No column name is repeated. So it follows the second rule of first normalization. To the values of rows, all the values are atomic. No attribute has a list of values in a particular row, right? So this table completely follows the first normalization form. And getting into the second rule of second normalization form, what it is that each non-prime attribute should be fully and functionally dependent on prime key attributes, right? We have already discussed that a prime key can be a single attribute or a combination of attributes, and the combination of attributes regarded as prime key, it is called as composite key, right? So first of all, let us see which attributes work as prime key attributes here, okay? We have 3 columns here and the fees is dependent on student number and course, right? The course is dependent on the student number and fees is dependent on the course, right? So overall, student number and course both combinedly determine the fees, right? So the student number and course act as composite key, okay? So here if we check, the fees is not only dependent on student number but also the course, right? But if you check clearly, the fees is dependent only on course, okay? Here we have 2 rows which have same course name Java with same fees 10,000 and 10,000, right? So the fees is only dependent on course attribute, not on the student number attribute. But with regard to the second normal form, the each non-prime attribute should be completely dependent on the prime key attributes, okay? So here we have 2 prime key attributes, student number and course, but fees is only dependent on the attribute course, okay? It is not dependent on the attribute student number. So this table does not follow the second normalization form. That's the reason why we have split our table into 2 new tables, okay? We can see 2 tables here with 2 columns, and the first table has 5 rows and the second table has 4 rows, right? Here the first table has 2 columns, namely student number and course. Here the student number decides the course, that is the student number itself is a primary key here and the course is a non-prime attribute, right? So the student number, the course is completely dependent on the student number, right? Which is a primary key, okay? Coming to the second table, we have 4 columns of fees, 5,000, 7,000, 10,000 and 15,000, which are completely dependent on the attribute course, right? So these two tables follow the second normalization form completely, okay? We are done with our second normal form and now let us get into the third normal form. To be in the third normal form, the table must be in second normal form. By the second normal form, it also means that the table must be in first normal form, right? And the another rule is that no non-prime attribute should be transitively dependent on primary key. By this, it means that, clearly understand here, the basic difference between the second normal form and the third normal form is that in second normal form, we have every non-prime attribute should be completely dependent on primary attributes, right? And in third normal form also, every non-prime attribute should be completely dependent on primary key attributes, as well as no non-prime attribute should be dependent on other non-prime attribute. In second normal form, a non-prime attribute can also be dependent on other non-prime attribute. The main rule is that every non-prime attribute should be completely dependent on the primary key attributes. That is the second rule. But in third rule, no non-prime attribute should be dependent on any other non-prime attribute. They should be dependent only on primary key attributes. Understood? Now, let us get into a simple example and understand it clearly. Okay? Here you can see 3 tables on your screen. Now, let us check for the first table if it satisfies the third normalization form or not. To satisfy the third normal form, the table must also satisfy the first and second normal form, right? So, let us quickly check that if this particular table satisfies the first and second normal form or not, okay? We have 3 columns here, name, date of birth and age, whose names are totally unique. We have 3 column names and 3 names which are totally different to each other. So it satisfies the second rule of the first normal form. And now getting into the values of each row, no particular row has 2 or more values under each attribute, right? We have only one value under each attribute for one row. So, this particular table completely satisfies the first normal form. Now, getting into the second normal form, we have 3 columns here, name, date of birth and age. Now, to check with second or third normal form, we have to first identify the primary key, right? Here, the primary key is name, okay? Because the date of birth and age can be same for 2 or more persons. So the date of birth or age cannot identify any particular row uniquely. So here the name identifies the each row of this particular table uniquely. So the name is the primary key here, okay? So now the date of birth and age are completely dependent on the name, okay? So this table satisfies the second normal form. Now, getting into third normal form, as I have already said that, we have a minor difference between the second and third normal form. In second normal form, any non-prime attribute should not be partially dependent on the prime key attributes, okay? If you have 2 or more prime key attributes, the all other non-prime attributes should be completely dependent on those all prime key attributes. It's not like if you have 2 prime attributes, it's not like other non-prime attributes are dependent on one prime attribute and not dependent on other prime attribute. It should not be like that. They must be dependent on all the prime key attributes, okay? And getting into the third normal form, there must not be any dependency of a non-prime attribute to another non-prime attribute. All the non-prime attributes should be dependent only on the prime key attributes. Okay. So here we have three columns: name, date of birth, and age, where name can decide the date of birth and name can decide the age. So, but here the age is also dependent on other attribute called date of birth, which is a non-prime attribute, right? So the date of birth also can decide the factor age. So this particular table is not in third normal form, as a non-prime attribute age is dependent on other non-prime attribute date of birth. Okay. So for this reason, we have split our table of 3 columns into 2 other tables of 2 columns each. Okay, with name and date of birth as attributes in our first table and date of birth and age as attributes in our second table. Here in our 2 tables, in the first table, the primary key is name, which completely decides the attribute date of birth. That is, the non-prime attribute date of birth is completely dependent on the primary attribute name. Okay, and in the second table, the date of birth is the primary key attribute which decides the age of that particular date of birth. I mean, that particular person who is born on that date. Okay, so these 2 tables satisfy the third normal form. So that's all about RDBMS. We have learned what a table is, about 3 normal forms, and how to form a table according to the 3 normalization forms, right? So in the upcoming videos, we shall learn about the basic syntax, data types, operators, and how to create a table, how to insert the data into the table, how to delete and how to fetch the information from the particular table that we have created. Okay, so we shall learn about all the different commands and different functions in the coming videos. Okay, that's all for today. Have a nice day. Thank you. Bye.